Okay, y'all, now we're going to talk about applications of the normal distribution. So if you take your notes, the formula for finding the normal variable x is x equals mu, which is the average, plus the standard deviation times the z-score. All right, let's do a couple of problems. All right, let's turn to page 337. And let's look at number 1. All right, number 1 says, the average early bird special admission price for a movie is $5.81. So that's your mean. If the distribution of movie admission charges is approximately normal with a standard deviation of 81 cents, what is the probability that a randomly selected admission charge is less than $3.50? Okay, all right, we're going to take our values. First thing we're going to do is find the z-score, which you remember is the value minus the mean over the standard deviation. So that's going to be $3.50 minus the mean, which is 5.81, divided by the standard deviation, which is 0.81. You always round to the hundredths place. If you punch that in, you'll get negative 2.85. Then you need to go to your chart, your z-score chart. You need to find negative 2.85. Less than is what the z-score chart gives you. That's going to represent your probability that that occurs, which is decimal 0.0022. Okay? All right, let's jump to number 11. All right, 11's got 3 parts. We're going to do all the parts. The average credit card debt for college seniors is $3,262. So that's my mean. Let's see. If the debt is normally distributed with a standard deviation of $1,100, letter A says, what's the probability that the senior owes at least $1,000? Well, at least means 1,000 and more. All right. So, let's find the z-score first. So it's going to be the x value, which is 1,000, minus the mean, divided by the standard deviation. Okay, if I go punch that in my calculator, round to the nearest hundredth, I get negative 2.06. I go to my z-score chart, I find that corresponding value, but it says at least, which means more than, which is to the right, so I have to subtract that score from my z-score chart from 1. And that gives me a probability of 0.9803, which means there's a 98.03 that the credit card debt is at least 1,000. Okay, if I go to part B, or more, I'm sorry. All right, let's go to B. It says that you owe more than $4,000. The z-score again. Okay, z-score is 0.67. This time though it says more than, again then, once I go and find my z-score value, my probability that corresponds to that z-score, I have to subtract that from 1. So my probability is 0.2514, which means there's a 25.14 chance that that senior owes more than $4,000. Okay, my last part in number 11 says the senior owes between $3,000 and $4,000. Okay, so I gotta find the z-score of both. So at $3,000, the z-score is negative 0.24. I go find the corresponding probability from the chart, which is 0.4052. I've already found the $4,000 from step B, so to get between those, I'm gonna have to subtract. So I'll use this score minus the score from the $3,000, subtract those, and I'll get an answer of decimal 3434. Okay. Okay, let's jump to 19. All right, 19 says a contractor decided to build homes that will include the middle 80% of the market. Okay, so that's what it's talking about. If the average size of homes built is 1,810 square feet, find the maximum and minimum sizes of the homes the contractor should build. Assume the standard deviation is 92 and the variable is normally distributed. Alright, so I know the average is 1,810. And I know the standard deviation is 92. Okay, since this represents the middle 80% of the curve, that means these two sections together represent 20%. So this represents 10, this represents 10. So I'm trying to find the 10th percentile and the 90th percentile. Okay, so if I take and change 10th or the 10% into a decimal, that's 0.10, this is 0.90. Alright, what I'm gonna need to do is I'm gonna go back to my chart and I gotta find the z-score that corresponds to this. And this is a little bit different now because this is the probability and I've got to find the z-score. So I have to look in this portion of my chart. So if I'm going to look for 0.10, I'm going to look for the closest thing in this section to 0.10. So it looks like it's on the back. I'm looking right here. The closest thing it looks like to 0.10 is, let's see, negative 1.28. Okay? So that z-score is negative 1.28. And then the other end is 0.90. So if I find the closest thing to 0.90, it's 1.28. And those will be symmetric like that. They should match. One will just be positive and one would just be negative. Okay? So if I get rid of this, let's go back and let's write down what we just found. Alright, so we got these two z-scores when we looked them up in our chart. Now there's a formula that you wrote down in your notes to find what this and this would represent. This is going to be a number from here to here that represents the middle 80% of the data, which that contractor was talking about. So the formula is the z-score times the standard deviation plus the mean and you're gonna subtract. Now when you add, you're gonna get the 90th percentile. When you subtract, you'll get the 10th percentile. So if I fill in, wait, hold on y'all. We don't need to subtract because I have two different z-scores, sorry about that. So my z-score, I'm gonna use the 1.28 first. The standard deviation is 92, and the mean is 1810. All right, I'll do the same thing with the negative z-score. Okay, I'll punch both of those in. This is gonna be the smallest number, this is gonna be the largest number. So if I punch that in, the middle 80% of the market for this contractor would be $1,692.24, and it's an interval, and the upper end would be $1,927.76. Okay, a little tougher, you gotta think about it. All right, let's do number 23. Okay, 23 says, an automobile dealer finds that the average price of a previously owned vehicle is $8,256. So that's my average. Okay. It says he decides to sell cars that will appeal to the middle 60% of the market. Okay, so if I take 60, subtract it from 100, that's 40. So that means 20% of the data is on the ends. So this is the 20th percentile. This is the 80th. So that's 0.20, this is 0.80. All right, it says find the maximum and the minimum of cars the dealer will sell. The standard deviation is $1,110, and it's normally distributed. $1,150. Okay, we've got what we need. We go to the z-score chart. We go to the middle of it. We find the closest z-scores that will give me this probability. If I go find those, remember they should be the same, just one positive and one negative. So this one is negative 0.84 and the other is positive. So if I fill back in my formula, the z-score times the standard deviation plus the mean, I'm going to use the negative z-score first. Doesn't matter though. 1150 is my standard deviation, and the mean is 8256. I'll do the same thing with the positive 0.84. I'll punch both of those in the calculator. This is going to give me the smaller end, the bigger end. So this automobile dealer, the middle 60% of the market would be 7,290 to 9,000.